Well, good morning, students. The topic that we are going to start today is reflection of sound. Does the sound gets reflected? Yes, it do gets reflected, and it follows the same law as we have studied in light. What does it say? Incident ray, normal, and the reflected ray all lie in the same plane, and the angle of incidence is equal to angle of reflection. This is the same thing which happens in the case of sound. Now let's talk about echo. You might have gone to monuments and some of the monuments, and you might have heard when you clap, you can hear it back. When you speak something, you hear it back. Okay. So now why it is happening? That phenomena is known as echo. Now the thing is that the sensation of sound persists in your brain for 0.1 second. So in order to differentiate between two distinct echoes, the time interval should be at least 0.1 second between those sounds. So let's see this. Speed of sound in air at 22 degrees Celsius is 344 meter per second, and as I said, at least there should be a difference of 0.1 seconds. So what should be the overall distance? If, for example, my voice is going from here and getting reflected back to me, so what should be the overall distance of that obstruction from me, from where it gets reflected and comes back to me? So first of all, the overall distance which the sound should travel before coming to me should be 344 into 0.1, so it is 34.4 meter. And as I said, what should be the distance of the obstacle from where it should come, where it should strike and come to me? It should be the distance of obstacle. I am just indicating it by DO. It should be 34.4 by 2, and this will become 17.2 meters. So this should be the minimum distance at 22 degree Celsius. This should be the minimum distance of the obstacle from me. Minimum distance of the obstacle from me, so that distinct echoes can be heard. Let's meet on Zoom. I will explain it more there.